gang. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Daniel Berosdi. I am from class B. Okay, today my presentation is about application of differentiation. Okay, let's go.
Hi, my name is Wan Haji Sufian bin Wan Zain and I'm from class B.
Okay. Hello guys, my name is Muhammad Izzat Adam bin Rasmi and I'm also from class B. Let's go.
This question is quite hard.
Yeah, I think so too. So, what do we do now?
We need to find someone can solve it.
Who can solve this kind of questions?
I think I know who can solve this question.
Who?
Hafiz!
Oh, Hafiz!
We need to find him now.
Let's go.
Hafiz,
Yes,
can you help me to solve some question?
yes, sure. What's the question?
This is the question.
Oh, let's jump to the slide.
Let's go.
We would like to express our special gratitude to our beloved lecturer, Sir Amiruddin Abdul Aziz, who gave us this golden opportunity to do this project on the topic related rate and graph of polynomial. We also sincerely thank our lecturer of Calculus 1, Sir Amiruddin Abdul Aziz, for his guidance and teach us in this subject. Last but not least, we would like to thank our group members who helped us in completing this assignment. So, for the introduction, in the differential calculus, related rate problems involve two or more variables that change at the same time, possibly at different rate. The rate of the change is usually with respect to time. So for objective in related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation that relate the two quantities and then use the chain rule method or implicit method.
Okay guys, let's see a problem statement. Okay guys, we see a question. The water is poured into a cylindrical tank whose height is 1/3 times the radius. If the volume increases at a constant rate of 2 meter cubic per minute, how fast the radius is changing when the radius is 3 meter? Okay guys, the solution. Okay, we choose one method to solve this problem. To solve this problem, we will use implicit differential methods. First, we need to write formula for volume of cylinder. The formula volume of cylinder is 1/3 pi r squared. Number 2, we need to identify two things. First, the given information. First, the given information is height is 1/3 times the radius. So we need to write h equals 1/3 r. Number 2, the volume increase at constant rate 2 meter cubic per minute. So we need to write dv/dt equals to 2. The third part is the unknown. How fast is the radius changing? When the radius changing, the radius is 3m. So we need to know dr over dt when radius is 3m. Number 3, we need to differentiate the formula. So we need to differentiate the cylinder volume formula. So we get 3 pi 1 over 3 hash. Number 4, we need to assign value of radius. We get dv over dr equals to 3 pi 1 over 3 multiplied 3 square. We insert hash to 1 over 3. The last part is we need to assign value for the rate and solve to get final answer. We know dv over dt equals to 2, dv over dr equals to 3 pi 1 over 3 r square. So we need to write dr over dt equals to dv over dt multiply dr over dv. So we insert the dv dt as 2 multiply 1 over 3 pi 1 over 3 multiply 3 square. So we get the final answer. We get dr over dt equals to 2 over 9 pi.
Okay, let's move on to the next part, which is the polynomial function. So what is polynomial function? Well, where the definition is, in this article, we'll be learning about the different aspects of polynomial functions. Polynomial is made up of two words, poly and nomial. Poly means many and nomial means the term. And hence, when they are combined, we can say that polynomials are algebraic expressions with many terms. Let's go ahead and start with the definition of polynomial functions and their types. So, polynomial functions is the simplest, most commonly used, and one of the most important mathematical functions. These functions represent algebraic expressions with certain conditions. They also cover a wide number of functions, and it is essential for one to study and understand polynomial functions due to their extensive applications. In this article, let's learn about the definition of polynomial functions and their types, and also the graphs with solved examples. Okay, let's move into the problem statement. Okay, so the question is, the polynomials are everywhere. It is found in the slope of a hill, the curve of a bridge, or the continuity of a mountain range. Based on the given information, answer the following question. Find the quadratic polynomial for the bridge if 6 is the sum and 8 is the product of its zeros. Okay, so here's the solution. To find a quadratic polynomial whose sum is 6 and the product is 8, we all know that the general quadratic equation can be written as x squared minus to the sum of zeros divided with x multiplied with x plus the product of zeros, given the sum of zeros is 6 and the product of zeros is 8. Hence, the required polynomial is x squared minus 6x plus 8.